Well, hello, everybody, and welcome to the first episode of H.B. Fuller's podcast, Battery Experts in the Know, where our experts talk about adhesive world and the EV industry as a whole. We're super excited today. So my name is Nathan Whitford. I'm our global product manager for our OEM and EV, or electric vehicle group, and I'll be your host today. We are really excited to have Elizabeth Knazs join us as our guest. Hey, Elizabeth, how you doing?
Good. How are you, Nate?
I'm doing well, doing well. Glad to have you. So today we're really going to talk about, not just the electric vehicle market and the battery industry, but we really want to understand a little bit about some of the technologies that H.B. Fuller has to offer to help support and solve problems for the market. So with that said, Elizabeth, can you first start off by telling us a little bit about your expertise and your role within H.B. Fuller?
Yeah, thanks, Nate. So I have about 20 years adhesive and sealant experience in multiple industries. But here at HB Fuller, I focus mainly on batteries and electrical vehicles. I'm a business development manager for the electric vehicle and battery space. And so I have a lot of information to share and trends that we're seeing. So I'm happy to be here and thanks for having me.
Yeah, my pleasure. And obviously we know each other for multiple years now. We've worked together, what, for four to 5 years, specifically in the EV market, I'd
Yes.
say. Yeah. So it's great to see you, and I look forward to hearing more about what you've seen in the industry. So why don't we kick it off? So the first thing I'd like to know from you is, as you've been out talking with your customers, really being at all the industry events in market events, what are you hearing as far as the trends, the mega trends, if you will, within the market? What are you seeing as the most, well, whether the most important or the more significant trends that are impactful for the EV industry?
Yeah, that's a good question. So a lot of things that, we continue to see is, you know, higher energy density for batteries, lighter weight, improving, um, fire safety is a big one that, you've seen the news is reporting those. So those are critical things that we're seeing, that are challenges for engineers every day.
Yeah, that makes sense. That's interesting. You mentioned the fire safety portion of it. So what type of technologies would help prevent fire safety within a battery itself?
So it falls under an umbrella, but you have your battery management system, but under beyond that, you have your thermal management system, which is electrical isolation, good heat transfer, so thermal conductivity, and then when you have a thermal event, thermal insulative properties become very critical to prevent the propagation in the event of a thermal runaway. So those are some key parameters of aspects that fall under the thermal management umbrella.
Okay, no, makes sense. Yeah. So let's dig in a little deeper. So you mentioned thermal propagation and products that prevent or help prevent or mitigate or reduce the risks of thermal propagation. Can you tell us a little bit more about what type of product line is that? What type of technologies are you talking about?
So I'm specifically talking about polyurethane foams. So they're lightweight, low density polyurethane foams that are flame retardant. So what happens is you have a thermal event. It's a very intense heat explosion with hot gases and some metal. When the CID goes off, you could have some metal debris. And what this material specifically does is you encapsulate the entire module. And typically the tops of the cells is recommended to prevent or protect the cells when gases come on top. And this is true for all form factors. So we're talking about prismatic, cylindrical, and pouch form factors. And so what it does is you have that high heat intensity, and the material's designed to create this char layer that prevents the heat from transferring to the cell that's overheated to the adjacent cells. So you can isolate it to one single cell instead of having multiple cells go off and actually losing maybe the entire vehicle or pack that you have or module. So it's a really good mitigation method, and I kind of see it as a seatbelt. It's your last layer of defense if all of your other defenses fail to prevent the thermal event.
Yeah, interesting. That's a good way to put it, I suppose. It's a way to protect against what could potentially happen, like an accident, like an unforeseen thermal event. Sounds like the product that you're describing is an encapsulant or a potting material that isolates that one cell so that when it goes off, it doesn't transfer the heat and explosiveness to the other cells around it. Is that correct?
Yeah, so I'm specifically referring to our EV Protect 4006 and 5006. Those are the polyurethane flame retardant encapsulants. And the 4006 is used in multiple, different vehicles on the market today. And that's semi-structural, so it's for cell to mod or pack level. And then, I'm sorry, cell to module level. And then the EV Protect 5006 we launched from more cell to module level, so it's higher structural strength, more rigid, higher durometer, but still low density and lightweight, very similar to the EV Protect 4006.
Okay, wonderful, wonderful. So those type of technologies, I mean, are those common within the market? Are there other options that are out there? Or what's the kind of the significance about maybe the EV Protect 4006 or 5006 versus any other encapsulant that perhaps we can offer to the industry?
Yeah, so when we started on this journey, I think it was back in like 2017, and our chemists, looked at the options that we have, and we make silicones, epoxies, polyurethanes. So there's many different options on the market. So when we looked at epoxies, epoxies tend to generate a lot of exotherm or heat generation in large masses, and obviously in a battery pack, that's something you want to avoid. So we determined that that probably wasn't the best technology. It's a little more rigid. So as you charge and discharge, it's going to put a little pressure on the cells and not allow them to expand and contract. Silicones, are good materials for high heat resistance, but they do not adhere well to substrates. They have lots of inhibition issues. And
Okay.
also, they outgas up to 7 days flammable hydrogen as they cure. So in a battery environment where you have mass production of batteries, it's just not a good fit. So we decided polyurethane foams were the best technology chemistry that we can supply to the market. And they're lightweight, they don't outgas, everything's consumed within the reaction. And also they're recyclable. So there's polyurethane foam recyclers, all over the country, where you could essentially recycle any waste or any excess polyurethane. So we found that it'd be a good sustainable solution moving to the future.
Nice. That's outstanding to hear. And it sounds to me that you mentioned it's lightweight. I mean, what type of density are we talking about? I mean, you say it's a lightweight foam, correct? So it expands after it's dispensed into the battery pack, it expands. What kind of density are we looking at?
So typically, our foam is 0.16 kilograms per liter
Okay.
expanded. Typical other materials out on the market about 1.21 kilograms per liter. And so really it's a significant weight savings and when you look at traditional materials that are used for potty materials.
Gotcha, gotcha. Well, that's very, very critical, as we all know, to the market because the less weight you can put into a battery, the further that battery can take your vehicle, right? So,
Yeah.
sounds like this material allows for a longer range than potentially other higher density type potting material. So that's really good to know. Um, can you tell the audience a little bit about how the product is dispensed within the module itself? And how much does it truly expand? So how much volume does a customer need to purchase, to fill their module itself?
Yeah, so this material is very low viscosity, about 600 centipoise. Roughly, the 5006 is a little bit lower in viscosity. And we purposely designed this in so it can get in between the small spaces. You typically, for cylindrical cells, you got about 1.2 millimeter spacing. With pouch and prismatic, it's slightly different. But it's able to get in there in between and help protect. And then it self-levels. So that's the important of the low viscosity, and then it'll rise 4 to 5x depending on the constraint layer within the battery. and then it'll rise up. So you need to use 1/5 of the material. And the key benefit to this is that with you, as we all know, like shipping costs have gone up, labor has gone up significantly
Yeah.
because of the world economic situation. So instead of having 5 trucks deliver your material, you only have to pay for 1 truck of delivery. And then, material handling cost is much lower and warehousing costs. So the floor space that you'd need in your warehouse will be significantly lower because you only need 1/5 of the material.
Yeah, that's pretty incredible, to be honest. Now the product that you mentioned, the EV Protect 4006 and 5006, it seems quite innovative, right? Doesn't the product itself, when was it developed, and how did we come to such a unique idea, if you will?
Yeah, we were in working in conjunction with some customers and gaining, customer feedback, and that's typically what HB Fuller does to, find new innovations and market gaps. And this is a gap that we saw. And so we went on this journey to create something that could meet this market need and give fire protection to the batteries. As we all know, this is a huge drive for government and for vehicles. So
Yeah,
that's
all
kind of
around
how
the
this,
world. Yeah.
yep, that's kind of how this came about. And it's been a really fun journey, and we just been learning a lot. And I think we have a pretty robust solution here to help make batteries safer for the future.
Yeah, and I've even heard that there was the product's been patented, right? The technology has been patented, which is an outstanding achievement. So congratulations on that.
Yeah.
So with that said, Elizabeth, uh, any other comments before we kind of button up our today's podcast?
No, just thank you for having me, and I look forward to all the different battery experts you have on your show. And I think we can help people educate themselves on trends and materials and where this market's going. We're in this together, all trying to make the world safer as we move to electrical vehicles and using lithium-ion batteries.
Yeah, I love that comment. One of the things I think HB Fuller strives to do is solve problems, right? And experts like you allow our customers to really work with us hand in hand with identifying what challenges they have. And then HB Fuller comes to the table with an innovative solution, but usually utilizing team members like yourself who have the expertise and know how to create the best practices for battery architecture with integrating the adhesives and sealants into that system. So really appreciate your time today, Elizabeth, and look forward to maybe having you back on another time. So thank you so much.
All right, thanks. Have a great day.
Yep, take care. Bye,
All
everybody.
right, bye.